嚟到第27條咧，係有關於基礎遺傳學嘅。咁我哋研究嘅咧就係啲烏蠅嘅遺傳病，就叫阿 Z 啦。咁啊呢個病咧係由一對嘅等位基因咧去控制嘅。咁而家啦，我哋就有兩隻烏蠅，一隻咧就係有病嘅雄性烏蠅，同埋一隻正常嘅雌性烏蠅。交配完之後咧，我哋就有120隻正常嘅雄性後代，同埋116隻有病嘅雌性後代啦。咁題目就問我哋啦，以下邊個配對咧係有關於呢個遺傳病 Z 嘅等位基因嘅特點係正確嘅喎？究竟啦佢係顯性定係隱性啊？究竟啦呢個遺傳病 Z 嘅等位基因啊，佢喺邊一度咧？佢係喺我哋嘅體染色體，即係頭嗰22對嘅染色體啊，定係喺最後一對第23對嘅性染色體 sex chromosome 咧？咁題目啦就梗係考翻我哋對於性連鎖遺傳嘅理解啦，同埋啦有咩辦法去區分得翻究竟啦嗰個等位基因佢係喺體染色體啊，定係喺性染色體咯？咁啊解呢條題目咧，我就用兩個嘅思考邏輯去解釋俾你哋睇。第一個思考邏輯咧，1A 同 1B 咧，我就當佢唔係性連鎖嘅，嗱當佢唔係啊嚇，咁我哋即管嚟睇一睇發生咩事咯。咁我先睇 1A 啦。我就當啦大街 A 係正常嘅等位基因，即係顯性啦。咁啊有病嘅等位基因咧就係隱性嘅，咁細街 A。咁而家我哋有一隻有病嘅雄性烏蠅，同埋一隻正常嘅雌性烏蠅。咁生到出嚟啦，1比1係嘛？1比1，咦？望落似似地喎，120同116又真係1比1喎，係嘛？跟住啦，又睇下1B 呢個邏輯咯。我就當啦有病係顯性，而冇病就係隱性。咁雌性嘅烏蠅咧係正常啊嘛，咁就細街 B 啦。咁啊雄性啦，喂有病喎，究竟係大街 B 定大街細街 B 咧？咁由於啦，我都係想做到呢個大約1比1嘅比例啊，咁所以應該係大細街 B 嘅。因為如果雄性呢隻有病烏蠅係大街 B 嘅話咧，生到出嚟應該全部都係有病㗎。係嘛？你用翻測交個原理你就明白㗎啦，係咪？咁所以啦，到頭來都係1比1。喂，好似樣喎，梁 Sir 啊，120對116咪大約1比1咯。咁而家啦，拎到出嚟呢兩樣嘢，咪又係大約1比1，大約1比1，係咪？好，其實我就想話俾大家聽咧，第一個思考進路咧，其實係根本唔使做嘅，其實係冇用嘅，係廢嘅。因為啦，我就算見到1比1咁又點啫？你諗下，睇清楚題目，題目係講係120隻正常嘅雄性，同埋116隻有病嘅雌性。佢呢度淨係講有病同冇病係1比1啫嘛，有冇講到性別啊？冇噶喎，因為一開始呢一個嘅推論，我根本就唔當佢係性連鎖，係咪？咁本身我哋睇個父母親，咁梗係有雄性同雌性啦，係咪？但係生到出嚟嘅仔女冇講過係雄性定雌性噶喎。淨係知道有病定冇病嘅啫喎，係咪？咁即係話啦，符唔符合到題目講俾你聽？120隻正常雄性同116隻有病雌性啊，冇講過。咁所以咧，其實呢個等位基因咧，極大可能就係一個性染色體上面嘅。咁啊 A 同 C 咧可以 say goodbye 嘅啦。咁只係爭在佢係顯性定係隱性嘅啫。咁有咩辦法條題目可能會搞到複雜啲？我哋要諗多啲咧。咁可能題目佢話啦，我俾多100隻咧，就係有病嘅雄性嚟嘅。因為有120隻正常嘅雄性啊嘛，都有100隻有病嘅喎。跟住啦，116隻有病嘅雌性咧，原來我都揾到啦，有100隻咧係正常嘅雌性嚟嘅喎。即係如果咁嘅情況底下啦，加埋大約400幾隻啦，400幾隻當中，咁其實都大約有一半係有病嘅，雄性好雌性好，大約一半啦係有病嘅，係嘛？亦都有另一半咧就係冇病嘅。要喺呢個情況底下咧，我哋嘅思考邏輯第一步1A 同1B咧，先好似有啲作用嘅啫。咁我哋繼續去咯，思考邏輯2咯。咁我哋有2A 同埋2B啦。咁我當啦正常嘅特徵咧，佢嘅等位基因咧係 X chromosome 啦，而佢係顯性嘅。大街 A， 咁有病嗰個啦，亦都係 X chromosome 嘅，就係呢個隱性嘅，咁Y 咪 Y chromosome 咯。跟翻題目啦，有病嘅雄性，正常嘅雌性，係咪？嗱，咁都係嗰句啦。因為點解我呢度揀佢係X 大 A X 細 A 咧？咁因為啦，我係想見得到咧，生出嚟都係有病有唔病啊嘛，係咪？得嘛？咁我見得到啦，有到頭來咧有啲正常嘅雌性，有病嘅雌性，正常嘅雄性，同埋呢個有病嘅雄性，得嘛？喺呢個情況底下啦，你會發現咧，咦，多咗啲嘢喎。 奇奇怪怪咁樣喎。因為啦喺個題目當中，佢冇講過有病嘅雄性喎，係嘛？亦都冇講過有正常嘅雌性喎。咁即係話啦，其實應該只係得呢兩款，就係正常嘅雄性同埋有病嘅雌性。咁所以其實呢個思考邏輯咧，其實都係唔吻合㗎。咁我講多一次啦，如果呢一隻雌性咧，佢係 X 大 A、X 大 A 咧，你會發現咧，其實生到出嚟咧，根本全部都應該係正常㗎，係嘛？正常嘅雌性同埋正常嘅雄性，係連呢個最基本嘅有病冇病嘅特徵都符合唔到啊，係嘛？所以呢個咧更加 say goodbye 嘅。我哋就睇埋邏輯 2B 咯。邏輯 2B 咧，咁我就當啦，有病嘅等位基因咧喺 X chromosome 咧係顯性，正常嘅等位基因喺 X chromosome 咧就係隱性。咁啊 Y 仍然都係 Y chromosome 啦。啲啦，有病嘅雄性 X 大 B 加個 Y， 然後啦冇病嘅雌性就係 X 細 B、X 細 B， 再生翻出嚟嘅時候啦，有病嘅雌性正常嘅雄性，咦？同我哋見得到嘅真係1比1咯，而呢個1比1係有埋性別嘅特徵喺當中喎，係咪？咁我就問啦，呢個等位基因係顯性定係隱性啊？咁自不然就係顯性啦，所以答案咧就係 boy 咯。嗱，咁啊題目就解完啦，提多一次大家啦。做呢類型基礎遺傳學嘅題目咧，有基因遺傳圖嘅就快手畫咗佢。你見我畫呢4幅圖咧，其實真係講緊1分鐘之內一定畫得晒嘅。我俾盡你分半鐘，係咪？你做一條 MC， 我哋希望半個鐘做晒36條，咁其實分零鐘少一啲啦。咁你話唔係嘅，我俾夠36分鐘自己嘅，咁1分鐘一條，其實畫4個真係差唔多噶啦。大家唔好懶清高咧，喺度諗咧，我要用心算。心咩算啊？係咪喺個腦度諗啊？不如畫低佢啦，係咪？Question 27 is about basic genetics, and we are talking about the genetic disease Z. And a fruit fly is controlled by a pair of allele, and we have a male fruit fly with genetic disease Z, and crossed with a normal female, would produce 120 normal male and 116 diseased female offspring. And which of the following combination regarding the allele of the genetic disease Z is correct? Is it dominant or recessive? And where is the allele located on? Say, are they on the autosome? That means from the first to the 22nd pairs of chromosome for the body characteristic, or for the 23rd pair of chromosome, the sex chromosome. So the question is checking us the concept about the sex-linked inheritance and ask us to distinguish the autosome and the sex-linked traits. So I use two thinking logics to show you how can we get the answer. So for the thinking logic 1A and 1B, I assume that it is not sex-linked characteristic. And then I let the normal allele is dominant, and then let the diseased allele be the recessive, big A and small a. So for the diseased male, small a, and the normal female, big A, small a. So why I use big A, small a, but not big A? Because I can see that for the offspring, or some of them, they are normal, and some of them, they have the disease. Therefore, it should be the heterozygous. And then finally, I get that, normal to normal, the ratio is 1:1. Okay. Seems like the ratio 1:20 to 1:16, right? And then what about I reverse the idea? Diseased allele is dominant, big B, and the normal allele is recessive, small b. Then we have diseased male and the normal female. So we still find that diseased and normal offspring, the ratio is also 1:1. And then you may say that, Mr. Leung, 1:1, seems like the number 1:20 to 1:16. Sorry. After showing you the thinking logic 1, actually I want to tell you that thinking logic 1 is useless. Because for the 1:1, it just talk about the normal and the diseased characteristic only. It doesn't tell you about, the normal offspring, is it male or female, or the diseased offspring is male or female. Both of the thinking logic, it doesn't tell you. However, for the question, it really tells you that it should be 120 normal male and 116 diseases female offspring. So we can conclude that the allele for the genetic disease Z they should be on the sex chromosome. So, is the allele dominant or recessive? We can proceed to the thinking logic 2A and 2B. Before we talk about it, I want to mention one more idea is that, what if the question, how can it make the logic a bit more complicated? What if it tells you that, apart from the 120 normal male, there are around 100 deceased male. At the same time, 116 deceased female, and we have around 100 normal female. So actually, if we add up the number, maybe 400 something, and then we add up the normal offspring, maybe 200 something, and then we add up the deceased offspring, also 200 something, and then it can make the thinking logic 1A and 1B a bit more logical, and then we can really use it to analyze the data. However, there is no such case. So thinking logic 1A, 1B, say goodbye. So thinking logic 2A, what I lack is that normal allele on the X chromosome, which is dominant, and deceased allele on the X chromosome, which is recessive, and Y be the Y chromosome. So we have the male, which is the deceased male, and we have the normal female, X big A and X small a, and then we can see that normal female, deceased female, normal male, and deceased male. So from this genetic diagram, we can see that it doesn't match our result. Because in the result, we never say that there is normal female. And we never say that there is deceased male. We only have deceased female and normal male. Therefore, for the logic 2A is also wrong. This assumption is wrong. This hypothesis is wrong. And some students, they may ask that, Mr. Leung, why do you use X big A and X small a, and why don't you use X big A, X big A? The reason is that if I use X big A, so all the offspring, they will be normal, right? So it will be normal male and normal female. It also doesn't match our result. So also say goodbye. And then we use thinking logic 2B. Deceased allele on X chromosome, which is dominant, X big B, and normal allele on X chromosome, which is recessive, X small b, and then let Y be the Y chromosome. Deceased male and with normal female. And then we can really find that deceased female and normal male. And the phenotypic ratio almost 1:1. And this 1:1 can really tell you deceased female offspring and normal male offspring. Therefore, thinking logic 2B is correct. The deceased allele on the X chromosome is dominant. So the answer is B. So after the whole question, one more reminder for you guys. When we are dealing with the basic genetics question, remember, drawing the genetic diagram as soon as possible. So you see that we only have maybe around 1 minute to finish one MC. So don't think that, I use my calculation to draw the genetic diagram in my mind. No, draw it on the paper. Directly get the answer.